In this video, we're going to talk about reducing rational expressions and, again, the variable restrictions that go with them. When I talk about reducing rational expressions, we're really talking about the same thing that we do with ordinary fractions. For example, if I had something like 5/35, we might rewrite that as 5 over the factored form, 5 times 7, and then cancel those what are called common factors. Cancel common factors, and the result would be, well, a 1 in the numerator and a 7, and this would be the reduced value of the fraction. Or in general, if we have, well, let's see, a over b divided by b is equal to a, provided b is not 0. Right? One common misuse of this with students at this stage, and I'm sure that this is going to be a handful of people throughout this course, so the sooner you smack the back of your hand for doing the following I'm about to show you, the better off you're going to be. You cannot cancel fractions over the addition or subtraction, right? These b's do not cancel. That would be like saying the fraction 8/3, which 8 is 5 plus 3 over 3, canceling that and having it be equal to 5. That's bad. So you can cancel the common factors in the numerator and the denominator of a fraction, provided they are factors, that is, separated by multiplication, but you cannot do so with addition and subtraction. You might be able to factor the numerator or factor the denominator and get those common factors to cancel, but you need to refrain from doing things like canceling individual terms top and bottom. So really quick, there's a difference between terms versus factors. So x squared plus 3x plus 2 has 3 terms. They are x squared, positive 3x, and positive 2. But x squared plus 3x plus 2 is equal to x plus 1 times x plus 2 when factored, and has 2 factors. And they are x plus 1 and x plus 2. So we can cancel common factors. We do not cancel common terms, which is what's going on up here. These are common terms versus common factors. It's kind of hard to read. Let me rewrite that. Common factors. So be careful. Okay, let's take a look at some examples and talk about simplifying these rational expressions and their domain restrictions. So, what are we on? Example 3. Reduce the rational expression and state the variable restriction, or restrictions, as there may be more than one. Okay. A. 5x minus 10 over x minus 2. The first thing that you should do here is, actually, even though this says reduce the rational expression and state the variable restriction, always state the variable restriction first. Now, the reason that we're going to do that first is because as we simplify this fraction, we may cancel out some common factors and lose sight of what the restrictions actually were to begin with. So what am I talking about here? Q of x, the denominator is x minus 2, and x minus 2 will equal 0 if x equals 2, and so our restriction should be x is not 2. Okay, next, factor both numerator and denominator. By the way, I'm using multiple colors here. In the past, I have had some students that had color vision issues, mild color blindness or color blindness in general. If anybody out there has any kind of color blindness, just email me privately. Let me know what colors are hard for you to see, and I will do my best to adjust accordingly. Okay? All right, so let's factor this sucker. We have 5x minus 10 over x minus 2. In the numerator, we can pull out the GCF 5, and we get x minus 2. And in the denominator, we can't do much. We just have a factor of x minus 2. But now we have these common factors. So, next, after factoring, cancel the common factors. And again, I'm making a big deal about the word factors there. So this is equal to 5 over 1. And this is, so no more common factors. And the expression is reduced to what's called simplest form. So that's another form that we're striving for, simplest form. So let's throw that definition in here really quick. Definition. A rational expression is in simplest form if the numerator and denominator have no common factors. Now, going back to this problem, we actually saw the following result. So let me move this back here out of the way. I kind of jumped the gun with that definition. I want to talk more about the result of this last problem. Result, 5x minus 10 over x minus 2 is actually equal to 5, provided x is not 2. So this was the original form. This is the reduced simplest form. And of course, the restriction. Now, why the restriction and what's going on here? Well, it turns out that if you want to say 5x minus 10 over x minus 2 equals 5, that's actually false because it has to be true for every single value of x. Now, if you factor this, let me move this down even further. As we did up above, this is 5 times x minus 2 over x minus 2, which can be rewritten as the number 5 times the quantity, x minus 2 divided by x minus 2. Now, in general, this fraction, this rational expression, let me not try to cram that into the corner. This rational expression of x minus 2 over x minus 2 is worth a value of 1 for all values of x except when x is equal to 2, which gives us 0 divided by 0, which is not equal to 1. That is, remember, undefined. So, to recap, 5 times x minus 2 over x minus 2 actually is 5 times 1 if x is not 2, which is then just equal to 5. So that's why we have the variable restriction. That's why we find out what the variable restriction is first in the original form before we simplify, because we could lose some of that restriction in our simplified expression. And it really turns out that this equals, saying that the left side is equal to the right side, isn't true unless you state that restriction. So more or less, if I were to break this down into a nutshell, this is just simplifying fractions. Although these fractions happen to be made out of polynomials, you're going to do the same thing that you do back up here when you're dealing with simplifying simple fractions. You're going to factor the top, you're going to factor the bottom, you're going to cancel the factors that they have in common. The only difference here is we need to look at what the domain or the variable restriction is before we get that process started. So let's take a look at some more examples. Let's continue example 3 a little bit more here. Example 3b. Same directions. State the domain restriction and rewrite the expression in simplest form or reduce it, and it will have x plus 5 over x squared minus 25. The solution looks something like this. Let's see. The first thing we'll do is our restriction. Maybe the first thing that we should do is actually factor everything, because we're going to need to factor to find our restriction anyway. So factor all quantities. Here that's x plus 5 over x plus 5, x minus 5. 2. Before reducing, state the variable restrictions. All right, well, if p of x is equal to x plus 5 times x minus 5, that will equal 0 if either x plus 5 equals 0 or x minus 5 equals 0, in which case x would then be negative 5 or x would be positive 5, and our restrictions are x is not plus or minus 5. So we can simplify that a little bit by writing plus or minus notation. And now 3, reduce by canceling. 2 L's in canceling? How many L's are in canceling? Let's ask Google. Nope. Well, whoops. 1 or 2 L's. Canceled. Yeah, both spellings are correct. Weird. All right. Well, I'm going to go with 2 L's. Sorry about the little diversion there, but apparently both spellings are correct according to Google. Reduce by canceling common factors. It looks a little bit weird now that I look at that word. Here, let's see. There, I'll have to put it in my phone later. Canceling. Anyhow, what do we have here? We have x plus 5 divided by x plus 5 times x minus 5. Or if you like, x plus 5 times 1. That looks like a crappy one. X plus 5 times 1 divided by x plus 5 times x minus 5, which will reduce when we cancel those common factors to 1 over x minus 5. So there's our simplified form. We're all done there. I just again want to note that if you look at the simplified form, 1 over x minus 5 here, you might just think that x can't be 5, but it turns out that's incorrect because you have to look at the original form. So, come on. From original form. So we want restrictions from original form. So our answer here, our result is x plus 5 over x squared minus 25 is actually equal to 1 over x minus 5, provided x is neither plus or minus 5. So there's our final answer. All right, let's take a look at one more. Oh, looks like I got 2 more. Let's get nasty. Okay. Example 3C. Reduce to simplest form. Sometimes simplest form is called lowest terms as well. And state variable restrictions. And this time they give us the expression 2m cubed plus 4m squared minus 6m divided by m squared minus m minus 12. So once you have the basic concepts down that we've been talking about in these previous videos, you're then expected to couple those ideas together with Chapter 6 and factoring. So this is just more factoring practice, and you're going to have to get pretty good at it. So here we go. 1. Factor, and this is equal to, let's see, in the top I have a GCF of 2m, and that'll leave me with m squared plus 2m minus 3. In the denominator, I'll try to reverse FOIL there. An m and an m, and 2 numbers that multiply together to give me negative 12 but add to be negative 1 feel like a negative 4 and a positive 3. Nothing seems to be canceling yet, but I have the denominator factored, and I could talk about what the domain restrictions are, but let's keep factoring. 2m squared. The top I'll try to reverse FOIL as well here. And I think if we have a positive 3 and a negative 1, the numerator will factor as such. And then we have m minus 4 times m plus 3 in the denominator. So, step 2, we'll find our restrictions. X minus 4 times x plus 3, the denominator. Q of x will be equal to 0 if x equals a positive 4 or a negative 3. So my restrictions are x is not 4 and negative 3. The next step would then be to cancel common factors. And it looks like I only have one common factor there. Maybe I should rewrite that guy again. Hold on a second. For anybody looking at these notes later without the benefit of the video, which I do not recommend. We cancel our common factor. And we have 2m times m minus 1 over m minus 4. You might not see it like that in the back of the book. You might say, they might multiply that back out now that there's no more common factors as 2m squared minus 2m divided by, oops, I almost wrote x there, divided by m minus 4 provided, I don't know, I wrote x up here. Why did I write x? Sorry, these are m's. All of these are m's. You just get locked into x mode all the time. M, 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 M. Provided m is not the number 4 or negative 3. Okay. Last call. Here we go. Example 3D. Same directions. Reduce and state the domain restriction, or so the variable restrictions. This one, though, xy plus 7x plus 4y plus 28 divided by xy plus 3x plus 4y plus 12. This particular expression has more than one variable. So we might have restrictions on both variables, but we don't know. So again, the first thing that we should do here is factor. So each numerator and denominator both have 4 terms. So let's do some factor by grouping here. For the numerator, xy plus 7x plus 4y plus 28. If we group the first 2 terms, we can pull out an x and we're left with y plus 7. In the second group, we can pull out a 4 and we're also left with y plus 7. And then we can factor that using GCF factoring again by pulling out a y plus 7, and the leftovers are x plus 4. For the denominator, we have, let's see, xy plus 3x plus 4y plus 12. We can group the first 2, and we can pull out an x, and we get y plus 3. We can group the second 2, and we can pull out a 4, and we also get y plus 3. And now that's equal to a common factor of y plus 3, with the leftovers x plus 4. This will allow me to take our original expression and rewrite it as the factored form y plus 7 times x plus 4 over y plus 3 times x plus 4. So we factored it. Step 2. Restrictions. Well, y plus 3 times x plus 4, the denominator. This guy right here. We don't want that to equal 0. So the first thing we do is we set it equal to 0. That gives us 2 different equations. Either y plus 3 equals 0 or x plus 4 equals 0, in which case y equals negative 3, or x equals negative 4. And these are our bad values. We don't want those. So our restrictions are this time on two variables. We don't want y to be negative 3, and we don't want x to be negative 4. So we now have the following. We're now going to cancel common factors in our third step, and those common factors happen to be x plus 4. Now this is a really good example for illustrating why you need to state your restrictions before you simplify. So y doesn't equal negative 3, and x doesn't equal negative 4. The reason it's so important that you state those restrictions is you'll notice this final form doesn't even have any x's in it yet. I have a restriction. So what does that mean? Well, it means that this form over here cannot be equal to this form here unless we have both of these restrictions. Otherwise, this right side will be just fine with x not equaling, or x equaling negative 4. But if x equals negative 4, this left side will have a denominator that's 0, and then they won't be equal to one another. Right? So what do I mean by that? So if x equals negative 4, then the denominator over here is going to be a 0 on the left side. Up top, we're going to get, let's see, negative 4y plus 4y is going to be 0, and negative 28 plus, we're going to get 0 over 0 is equal to y plus 7 over y plus 3. That's nonsense. So watch out. Okay. That does it for variable restrictions and reducing rationally.